Alright, so we're going to continue our 2D side-scroller series here. Right now, where we left off, the character can move. We have these different physics materials on the floors that have various frictions. Um, but the next step I want is jump. So if we want to add a new feature to our game, that's going to come through scripting. So let's return to the player character script that we've started and start thinking about adding jump. Well, a couple of things. First of all, it's good practice to just get rid of stuff you're not using. So at this point, we're not using the start function. So let's go ahead and just clear that out. And we'll just keep doing a little bit more housekeeping while we're at it. Um, it's also good practice to kind of keep your update functions nice and easy to read. So right now it's only doing one thing. Like essentially this is only moving the character. That's all it's doing. But since we're about to add support for jump, things are going to get a little more murky. So just to keep it crystal clear what's involved with jump and what's involved with move, let's go ahead and refactor this movement code into its own function called move. It's good to name functions after what they do. It just makes it easier for you and other programmers to understand what the intent of the code is. So I'm going to select these lines, and in Visual Studio on Windows at least you can hit Control period to bring up the quick action menu, and the quick action available to us is extract method. So I'm just going to hit enter because this is what I want to do, and we have to name this new method. And I'm just going to name it move, and I'm going to hit enter. And so now inside of fixed update we only have this one line of code that's called move, and it's calling the move function, which just does exactly what used to be happening, except now it's named better and it's cleaned up our fixed update function here. Alright, so now that our move code is nice and cleaned up, what we want to do is start working on jump. Now, if you remember, we put the move code in fixed update because fixed update gets called at a slower interval than update. And fixed update is adding a force across multiple frames, and that can be expensive. So we want to call it at a slower interval than in update. On the other hand, we're checking for input in update because we want the game to feel responsive. So we want to immediately update the input as soon as we can detect the players pressing something different. Well, jump is going to work a little differently because jump will only affect a single frame of our game, because it's only going to be called when the player presses the jump button. We can just go ahead and detect the input and affect the player's physics inside of the update function. So I'm just going to start coding jump directly in update, and then once we're finished we can think about how we want to rename it and refactor it into its own function, kind of like we did with move here. So the first step is going to be detecting the input. So we're going to say something like if input.getButton, and input.getButton works similarly to getAxis in that it uses the input manager. So we have to look up what the name of the button that we want to use in the input manager is. So let's go back to Unity, and we'll go to Edit, Project Settings, Input, and we can go ahead and collapse some of these that we don't care about right now, and you'll see there's actually already a built-in input for jump, two actually. One is bound to the space bar, so that works well for keyboard and mouse control schemes, and there's actually a second jump down here that's bound to like an Xbox 360 gamepad, which would be like the X button for jumping, I think, or maybe it's A, I'm not sure. Probably A button. You can look it up. But either way, we want to use this built-in jump because it's going to support us with some pretty standard um, controls for both the keyboard and the gamepad. So what we can do if we are bad at typing is just copy this jump and then go back to our code, and we will just type in with Control V to paste the exact name of that input from the input manager. And so if the player presses the jump button, what do we want to do? Well, we want to add a force to our player in the upward direction on the y-axis. So we need to go back to our rb2d.addForce function. And again, this time it's safe to go ahead and put it in update because this, actually, now that I look at it, I'm using the wrong function here. We want to actually use getButtonDown. If you look at what getButtonDown does, it returns true only during the frame the user presses the button down. So this can only get called once each time the player presses the jump button. We don't have to worry about it getting called like super fast, like if they're holding a button down. And it's probably useful to note that just input.getButton will test if the player's holding the button. So if you wanted like a jetpack or something, you could do this, and then you would want to move it down into fixed update. But because we only care about a single one-off button press, we want to know if we want to use getButtonDown. And so this can only get called once a frame, so it's safe to go ahead and leave it in update. And so when they press the jump button, we want to add a force in the upward direction on the y-axis, and so that means we want to multiply this force times vector2.up, right? And the next question is how much force do we want to add? We've got the direction, but what about the magnitude? How big of a jump do we want? And again, we could just hard code some magic number here, like 100 or whatever, but we want this to be easy to tweak. So it's better practice to make this a variable and expose it to the editor so that our designers can customize this and fine-tune it easily. So somewhere in between my max speed and my rigid body serialized field, I'm going to make a new serialized field to expose the private variable jump force. So private float jump force. And I'm just naming it jump force because that's what it is. This is the force we're going to add to our character when they press the jump button, when the player presses the jump button. And we should give it some sort of initial value. Again, I have no clue what's going to be good. That's the reason we're exposing it to the variable, because we want it to be easy to tweak. So we can just type a number in here. We'll type 10, whatever. And so we're going to add a force vector2 up times jump force. Now, we could just put our semicolon here and call it a day, but in this case, jump is going to work a little differently than move. For our movement, we're trying to sort of accommodate this acceleration feature, right? Like the character may take some time to get up to their full speed. But with jumping, we want the player to just jump as soon as the player presses the button, right? We can't count on a player holding down jump for a long time, at least not for now. Maybe that is something we want to think about later, but for right now, I want this jump to feel like immediately responsive. So what we'll do is we will add a comma after the vector2 up times jump force, and we're going to try to use a different force mode 2D. So the normal force mode 2D, the default one, is just force, and that's what we're using for our movement, and that sort of factors in the slower acceleration over multiple frames. But impulse will sort of immediately add an instant force to it, which is going to make our jump feel more instantaneous and sudden and responsive. So we'll try using that for jump. Alright, let's go ahead and save the game, and we'll go back to Unity and see if this works. So if I click on my player character, we should now see we have this jump force option. And if I run the game and I press spacebar, sure enough I jump. Now this to me feels like a really high jump, and it also feels like it takes me a long time to fall back down. It's kind of floaty. So what I want to do to make my character kind of fall faster, I'm going to change the gravity settings of my game. So to do that, you need to go to Edit, Project Settings, Physics 2D, and here in the inspector now we'll see the Physics 2D settings, and what I'm interested in is this gravity. And you can see by default we have like a kind of a realistic negative 9.81 downward gravity force. But when I play my game, you know, games aren't necessarily realistic. And if you're used to something like Mario, the character doesn't sort of float around in the air that way. They fall faster. So let's just try something a little bit faster, like 20 or 25 or 30. So I'm going to try negative 25, and then I'll run the game and see if that feels a little better. So now with the gravity set to negative 25, if I jump, it's not nearly as high because it takes more to, you know, the downward force of gravity is pushing harder, so it takes a bigger jump force to get that high. And I'm falling a lot faster too. And to me, this actually feels kind of like a decent game's jump. So we will leave it be like that. But now I can, now that I've cranked up gravity, I can actually tell that movement doesn't work anymore. This is because it's the higher gravity is it's making our higher friction we set on the player more drastic. So you can kind of see if we're on this ice, we can still move because there's not as much of a friction to fight against. But if we just get on the default ground here with the default physics material, I can't even move anymore. So that's something we're going to have to tweak again now that we've changed gravity. So what I'll do is go back to our physics materials. Let's take a look at the player friction, and let's just maybe, we kind of doubled the gravity, so let's maybe have the friction and see if that kind of gets us back to where we were. So yeah, it's I feel like it's really hard to get going, and I can't even move at all on this. So maybe I just need to find the right balance between friction and then acceleration on my player. So if I go back to the player character, maybe I want this acceleration force to be even higher. And, you know, I'm moving. It feels a little not quite perfect to me, but we'll keep working on it. So for now, this is at least playable, and we have a jump. Now, what you might notice is that jump can continue to be pressed forever. And what we are looking for is a jump that sort of works again like a Mario game or most platformers where you can only jump if you're on the ground. So in the next video, we're going to start trying to figure out how do we tell if the player's on the ground, and then only allow a jump if the player's on the ground, so you can't do this infinite jump like we have now.